Welcome to video lectures on signals and systems. This is Dr. V. Padmanabha Reddy, Professor of ECE. Signals, so course name is Signals and System. Course code is AEC02. Lecture 1, Operations on a Signals. Today we are going to discuss about operations on a signals. Operations on signals are transformation of independent variables and transformation of the dependent variables. Signal operations involves the modification of independent variable or modification of the dependent variables. Signal operations also allows the properties of the signals. Let us consider some signals. Let us consider signals like x of t equal to a cos t, where a is the amplitude of the signal, t is a time. Where you see the x of t values of x of t depends on t values. So x of t is called dependent variable, where t is called as a independent variable. Okay, you see suppose you perform operations on a, you get the amplitude operations. You perform operations on a, that is called amplitude scaling, amplitude shifting operations, and sometimes two or more signals are added, you get the addition operations or subtraction operations. Sometimes two or more signals are multiplied, you get the multiplication operations. These are all based on the amplitude operations. And one more thing is t. If you perform operations on a t, that operations are called as operations on a independent variables. Operations on a independent variable. You see, that's why the signal operations can be classified as operations on a dependent variable, operations on a independent variables. And also, when you perform operations on a amplitude, it does not affect onto the time. If you perform operations on a t, it does not affect onto amplitude of the given signals. Let us discuss about operations on a dependent variable, such as amplitude scaling, amplitude shifting, multiplication addition operations, and differentiation integration operations. Let us move to amplitude scaling operations. If amplitude scaling operation is performed on a input signals, resulting signals may be a amplified version of the input signal or attenuated version of the input signals without changing of the shape of the signals. Let us consider some signal like x of t, and y of t is a response of the x of t. And if you perform amplitude scaling operation on x of t, resulting signal y of t, that equal to a times of x of t, a times of x of t. Where a values are greater than 1, the y of t is a amplified version of the x of t. When a values are less than 1 and 0 is less than a, between the values of 0 and 1. Under this condition, the y of t is a attenuated version of x of t. And also one more point is, always a value must be positive value for the in amplitude scaling operations. A must be positive. A is any scaling parameter which is positive only. Let us consider some simple example. Let us consider x of t equal to 1 for minus 1 less than t less than 1 and 0 for the otherwise. If you draw the signal, plot the signal between the t versus x of t values, we get the x of t value equal to 0 for when t is equal to less than minus 1, and also 0 for the when t equal to greater than t1 value. If you plot the t versus x of t, we get the pulse. Width of the pulse is equal to t1 minus of minus t1, you get the 2t1 is the width. The height of the pulse is equal to 2. This is given signals. Now we can perform a scaling operation, but assuming that a equal to 2. A equal to 2. That's why y of t equal to 2 times of the x of t. 2 times of x of t. So now you can see the performance. Let us see that I am considering for the t values are less than minus t1. The y of t equal to, you know that 2 times of the x of t. 2 times of, when x of t value become a, when t less than minus t1, x of t value equal 0 into 0, that become a 0 value. That's why we draw, we plot y of t versus t, we get the t less than minus t1, y of t value equal to 0, 0, 0. You see that, this portion, you can see this is the t0. Suppose t value lies between the minus t1 to plus t1 values. Y of t value equal to 2 times of, you know that minus t1 to plus 1, x of t value equal to 2. 2 into 2, we get the 2 into 2, we get the 4 value. That's why I am drawing for between minus t1 to plus t1, y of t value equal to 4. So for t equal to greater than t1. Under these conditions, y of t equal to 2 times of, where the x of t value becomes 0. That's why y of t equal to 0 for t greater than t1. We get the sum pass. You observe that in this case, it is the amplitude of the y of t, it is nothing but a, y of t is a amplified version of the x of t. The amplitude of the signal is increased by amount of 2. This is about the y of t is a amplified version of the x of t. Next, we go for the next attenuated version. You see, suppose a values are lies between the 0 and 1. 0. Let us consider next case attenuated version. We consider a equal to 0.5. Now y of t equal to 0.5 terms of the x of t. You plot t versus y of t. First you consider t equal to less than minus t1 value. And y of t value become a, because when t less than t1 value, x of t value equal to 0, 0 into 0.5, it becomes 0. Next, when t values are lies, minus t1 less than t less than capital T1, y of t value equal to 0.5 terms of the, when x of t value is between the interval of minus t1 plus 1, the value equal to 2, 2 into 0.5, it gives the 1. That's why this value, minus t1 plus t1, the value equal to 1. Next, when t equal to greater than t1 value, y of t value equal to 0.5 times of, when x of t value t greater than t1 becomes 0, 0 into 0.5 equal to 0. That's why we get the t greater than t1, y of t value equal to 0. We observe that in this case, y of t is a amplitude will be y of t is a attenuated version of the x of t. This is about the amplitude scaling operations. And you see the same amplitude scaling operations for the discrete time signals. This is a x of n. We can define x of sample values, x of n versus x of n. We plot the n versus x of n. X of n value 0 for n equal to 0, and 1 for the n equal to 1, 2 for the n equal to 2, and 3 for the n equal to 3 for x of n 0. When n equal to minus 1, the value of x of n equal to 1, n equal to minus 2, value of x of n equal to 2, n equal to minus 3, value of x of n equal to 0. This is the first one. Now you can see that, now we can attenuate it. First we discuss the amplified version of the x of n. That I am considering for the y of n equal to 2 times of the x of n. 2 times of x of n. Let us discuss about these things. You see that when y of minus 3, y of minus 2 times of the x of minus 3, you know that x of minus 3 value equal to 0. That's why 2 into 0, we get the 0. That's why this is y of 0, y of minus 3 equal to 0. Similarly, if n equal to minus 2, y of minus 2 equal to 2 times of x of minus 2. X of minus 2 value equal to 2. It is 2 into 2. You get the 4. That's why this value equal to 4. Next, n equal to minus 1. For n equal to y of minus 1 value equal to 2 into x of minus 1 value equal to 1. That is not equal to 2. That's why this value equal to 2. Next, for n equal to 0, y of 0 equal to 2 times of the x of 0. So x of 0 value equal to 0, 2 into 0 equal to 0, that's why this value is 0. Next, n equal to 1, y of 1 equal to 2 times of x of 1, that equal to 2 into x of 1 value equal to 1. 1 into 2 equal to 2. That's why this value equal to 2. N equal to 2. Y of 2 equal to 2 times of x of 2. That equal to x of 2 value equal to 2. 2 into 2, we get the 4. This value equal to 4. N equal to 3. For n equal to 3, y of 3 equal to 2 times of the x of 3. That equal to 2 into 0. That gives the 0 value. Like this, so we get this value, so we are getting 2 times. This is amplified version of the y of an amplified version of the x of. Similarly, we are finding for the alternative version. In alternative version, similarly we are finding for n equal to minus 3, y of minus 3 equal to, for this case, 0.5 times of x of minus 3. X of minus 3 value equal to 0. That means the value will become 0. N equal to minus 2. Y of minus 2 equal to 0.5 times of x of minus 2. X of minus 2 value equal to 2. 2 into 0.5. 2 into 0.5 equal to 1. That's why this value equal to 1. Y of minus 1. 0.5 times of x of minus 1. X of minus 1 value equal to 1. 0.5 into 1, you get the 1. Sorry, 0.5. You get the 0.5. Y of 0 equal to 0.5 times of x of 0. X of 0 value 0. That's why y of 0 0. And y of 1 equal to 0.5 times of x of 1. X of 1 value equal to 1. 1 into 0.5, you get the 0.5. You get the 0.5. And n equal to y of 2. Y of 2 value equal to 0.5 times of x of 2. X of 2 value equal to 2. 2 into 0.5 is equal to 1. You get the 1. Remaining value 0. Like this, this is alternative version of the x of. With this scaling property, scaling version is over. Let's move to the next operation on a signals, is the amplitude shifting operation. The amplitude shifting operation can be obtained by adding of a DC component to the signal that gives the amplitude shifting operation. The original signal can be more when adding for constant value to the any signal, the resulting signal may be a shifted version, vertical shifting version of the original signals. Vertical shifting may be upward direction or downward direction. That is called as amplitude shifting. If you add any DC component to the signal, resulting signal may be shifted upward direction or downward direction. This is called nothing but vertical shifting operations. That vertical shifting will be depending upon the constant value. If constant value is a positive value, it shifted upward direction. If constant value is a negative value, shifted in downward direction. Let us discuss about this one. If you perform an amplitude shifting operation on x of t, the resulting signal is equal to y of t equal to k plus x of t. In case of the continuous signals. In the discrete time signals, x of n is a input signal, and if you perform an amplitude shifting operation on x of n, resulting signal is equal to y of n, that is given by the k plus x of n. Where k values are, the k value decide the either shifting vertically upward direction or shifting vertically in downward direction. So if k equal to positive values, then shifting upward direction. When k is equal to shift upward direction, when k is equal to negative values, the signal is shifted in downward direction. Okay, let us discuss about by considering some example. Let us take some example. Okay, let us consider some signal. X of t equal to 0 for t less than 0 and t greater than 2, and 1 for between interval of 0 and 1, and minus 1 for the between interval of 1 and 2. Okay, this is a given signal. Now we can perform the amplitude scaling operations. Assuming that the case scaling may be amplitude shifting, shifting operation by adding 1 to x of t. By adding 1 to x of t, resulting signal equal to y of t equal to 1 plus x of t. 1 plus x of t. If here k value equal to 1, here k value is equal to minus 1. Let us discuss one by one. Let us see. Suppose this is the input signal, this is output signal. It is nothing but a shifted upward direction, this shifted downward direction. because this k value equal to minus 1, this k value equal to plus 1. Let us discuss. Suppose let us see for a case of t is equal to less than 0. For t less than 0, you see that this values. What is with the t less than 0, x of t value equal to 0 and this x value 0, then y of t value become a 1 plus 0. 1 plus 0 become y of t equal to 1. For t less than 0, y of t equal to 1 plus x of t, and if t less than 0, x of 1 plus 0 equal to 1. That's why we draw for t less than 0, y of t value equal to 1. For t equal to, t value lies between the 0 and 1. Under this condition, y of t equal to 1 plus, whereas x of t value become a, x of t value 0, between the interval of 0 and 1, x of t equal to 1. 1 plus 1, that gives us 2. That's why this y of t value become a 2 value. Between the t values lies between the 1 and 2. Between 1 and 2, y of t value become a 1 plus, where x of t become a minus 1. You see the x of t value equal to minus 1 for the between interval of 1 and 2. The minus 1 minus 1, that become a 0. Y of t value become 0. And t equal to greater than 2. When t equal to greater than 2, y of t equal to 1 plus, when x of t greater than 2 means its value becomes 0, that becomes 1. That's why you get the 1 value. Also you observe that x of t value varies about the line y equal to 0. Where in case of the y of t values varies about the line y equal to 1. So it is shifted, the y of t is shifted about the in vertical direction by amount of 1. Just 1. Next you can see the k is equal to minus 1. When k is equal to minus 1, similar way I am finding. Let us consider for t equal to less than 0 case. When t less than 0, y of t equal to minus 1 plus x of t. Suppose t less than 0, what is x of t value? X of t value equal to 0. When t less than 1, less than 0, x of t value is 0. That's why minus 1 plus 0, you get the minus 1. That's why you get the minus 1 value for the y of t values. This is the case. Next, when t equal lies between the t values lies between the t equal to less than 0 and 1. Between 0 and 1, y of t value equal to minus 1 plus x of t value become a 0, 1, this value equal to 1. 1 minus 1, this become a 0. That's why you get the, this is 0 value. Next, when t equal to 1 and 2, between 1 and 2 intervals, y of t become a minus 1 plus x of t value equal to minus 1. That become a minus 1 minus 2. This become a minus 2. This is a minus value equal to minus 2. When t equal to greater than 2, y of t value become a minus 1 plus x of t value equal to 0. No, it is become minus 1. The signal is moved downward direction. This is moved downward direction. It moved in upward direction. This is called as a the signal is when you are adding any DC signal or constant value to the time varying quantity, the signal is moved in upward direction or moved downward direction depending upon the k values. If k is a positive values, you move upward direction. If k is equal to negative values, you move the downward direction. This is called vertical shifting operations. Next operation is addition, subtraction or multiplication operations. In this case, we are adding the two or more number of signals can be added or subtracted or multiplied. In addition operation or multiplication operation, subtraction operation will be performed based on the time by time based. Let us consider two signals. Let us x1t, the x1t equal to 1 for between the interval of minus 3 plus 3, otherwise the value equal to 0. And x2t between interval of minus 10 to plus 10, the value equal to 2 and 0 for the otherwise. These signals can be addition operations. These two x1 and x2 signals are two are added. Adding signal is given by the z of t equal to addition of the x1t and x2t. Now you can see that according to operations, time by time operations, you see the when t value considers t equal to less than minus 10. Under this condition, what happens? You see that the when x1 t value equal to 0 for t less than minus 10. For in case of the x2 t value also 0 for the t less than minus 10. By adding of 0 and 0, we get the 0 value. This is for the z of t. Z of t value becomes 0. Now we can consider for second time interval. Let us, I am considering for the minus 10 is the less than t less than minus 3. Under this condition, you see the x1 t value become a minus 10 to, it is a minus 10, minus 10 to 3, the x1 t value equal to 0, whereas in case of the x2 t value become a 2, minus 10 to some minus 3, minus 3. This value 0, x1 value equal to 0, x2 value equal to 2, 2 plus 0 equal to 2. Wait, 2 plus 0 equal to 0. Now z of t value become a 2 plus 0 equal to 2. This is a 2 value. Between interval of minus 3 less than t less than plus 3 value, you see that for this x1 t value equal to 1, whereas x2 value equal to 2, 2 plus 1 equal to 3. Between interval of minus 3 to plus 3. And between interval of t values lies between the 3 and 10. 3 and 10. x1 t value equal to 0, we will take t 10 here. This value 0, 0 plus 2 will become a 2. Z of t value equal to 2. For t equal to greater than 10, when t greater than 10, x1 t value equal to 0, x2 t value equal to 0, and adding of both, we get the z of t value also 0. This is a operation, time by time addition operations. The amplitude will be added for time by time. This is for the addition operations. Similarly, we go for the multiplication operations. Multiplication operations also similar way as that of the addition operations. First, we consider for the between interval of t values are lies between the minus 5 to minus 3. You see the by you consider z of t equal to x1 t multiplied with x2 t. x1 t multiplied with x2 t, we get the z of t equal to x1 t, x2 t. Let us see between interval of minus 5 less than t, t less than minus 3, x1 t value equal to 0 into it has some values are there. Minus 4 to minus 3 is value 1, minus 4 to minus 3 is value equal to 2. That's why 0 into this value, so we get the z of t value become 0. This minus 5 to 5, the value becomes 0. Between interval of t values lies between the minus 3 less than minus 2. Under this condition, you see the red line, the slope line. When you can slope line is multiplied with this one value, x1 value equal to slope line, and x2 value equal to 1. 1 into slope, we can get the same slope. We are getting the same slope between interval of minus 2 to minus 3. Next, between interval of minus 2 less than t less than minus 1. You see the minus 2 minus 1, x1 t equal to 1. 1 into is also 1. Minus 2, x2 also 1. 1 into 1 equal to 1. Next, t values between interval of minus 1 less than t less than plus 1. Between interval of 1 minus 1 plus 1, value equal to 2. Whereas in this x2 value equal to minus 1 to plus 1 is value equal to 2. 2 into 2, we get the 4. That's why you get the 4 value. The 4 value. Okay. Next, you can see that 1 and 2, t less than between 1 and 2. 1 and 2, x1 t equal to 1 and x2 t equal to 1. 1 into 1, we get the 1. The yellow line. And t equal to between interval of 2 and 3. Between 2 and 3, there is red line, this indicates slope line. Slope line multiplied with the x2 value equal to 1. 1 into slope line again, it becomes same, we are getting same slope between interval of this one. That's why we get the same slope we are getting. Next, you can see that the t values are lies between the 3 and 4. Between 3 and 4, x1 value equal to 0, when x2 value equal to some 1 value, 1 into 0 also 0. 4 to 5 also, x1 t value equal to 0, and x2 t value, some value is there. Some value multiplied with 0. 0 multiplied anything is also 0. That's why you get the 0 line. This is about the multiplication operations is performed on a signals. Next you can see the differentiation operations. Y of t. Just we see that this is a, we get any signal x of t, dn by dtn, and output signal is y of t. Y of t equal to dn by dtn x of t. Suppose it's simple and first derivative. Let us consider some circuit like this, RC circuit. And also we consider for the RL circuit also, C. We also consider for RL circuit. L. You see the RL circuit. In RL circuit, the output value given by the some VL of t. Where VL of t given by the L di of t divided by dt. Where I of t is nothing but a current passing through the inductor. That's why it gives the I of t is an input signal, VL of t is an output. This gives relationship between the derivative of the first derivative of the current signal is nothing but a voltage across the inductor. Similarly, you see the RC circuit. In case of RC circuit, the current passing through the circuit is I of t, whereas the voltage across the C is given by Vc of t. Vc of t given by 1 by C integral of I of t into dt. You see that in this integral, first integral of the Vct is given by integration of the current signal, where I of t is the input, where Vct is the output. Okay, it gives relationship between the IT and the U of t. Like this, the circuits can be indicating by integration operation as well as the differentiation operations. Okay, next you see this. Suppose if one find the area under the any signal. If you see in case of signal is odd signals or odd symmetry, area under the signal equal to 0. In case of the even signals, area under the signal equal to twice that of the either side of the signals. It already is discussed in even ordered property. This is about the operations on a dependent variables. Next you go for the next step. Operations on a independent variable. That means you know that any function x of t, where t defined as a independent variable, where enter x of t called as dependent variables. Now I can perform an operation at t. That is x of t equal to some cos t. Now I can perform an operation on a t. T is an independent variable. Let us see time, because it is now t can be considered as time. That is called time scaling operation, time shifting operations, and time reflection or folding or reflection operations. Time reversals. Let us go for the time scaling operations. In time scaling operations, the independent variable multiplied with any constant. The constant must be a real positive constant. The constant must be real constant. Let us see the x of t is a x of the signal. I multiply the t multiply with any scaling parameter. Say a is a scaling parameter. The a value must be positive. Always is positive. And also it is real number. Now y of t is a time scaling operation of the x of t. X of a times of the t. Now a t equal to some tau. T equal to tau by a. T equal to tau by a. Y of tau by a. Now you can see that. But when you perform a time scaling operation, it does not affect the amplitude of the given signal. Let us see. Let us consider x of t signal. X of t signals. You perform a time scaling operation. A equal to 2. When a equal to y of t is a time scaling operation of the x of t by amount of 2. X of 2t. X of 2t. What happens? Simply the time scale version of the x of t given by the time base will be divided by some 2. Because a value equal to 2, 1 by a actually is 1 by a equal to 2 means minus 1 by 2 plus 1 by 2. What happens? Minus 1 by 2 value become 0.5 and plus 1 by 2 value become 0.5. Okay, that's why the signal is observed that the signal is nothing but a compressed version of the x of t. Y of t is nothing but a compressed version of x of t. Okay. In this case, you observe that compressed means suppose x of t is any recorded audio tape recorded tape. Suppose if time can be scaled by amount of 2 means the speed of the recorded speed of the tape is played with double the speed. Whereas in case of the a equal to 1 by 2, in a equal to 1 by 2 means you see that this A value become 1 by 2, 1 by 1 by 2. It become minus 2. 1 by 1 by 2. We get the plus 2. Between minus 2 plus 2, we get the say y of t equal to x of t. This is nothing but the expansion version of the expanded version of the x of t. But in this case, the recorded tape is played half of the speed when compared to the original speed of the signal x of t. Similarly, you see that in this case, we know that x of n is a discrete time sequence, y of n is a x of 2n. Now you can see that every value will be divided by 2. 1 by 2, 2, 2, 2, 2 and 2. What happens? 1 by 2, 1 by minus 2 by 2 is minus 1. What is x of minus 1 value? X of minus 1 value equal to nothing but 1. Similarly, x of you see the 1 by 2. That means if we substitute y of minus 1, y of minus 1 equal to x of minus 2. What is x of minus 2 value equal to 1? It's 1. Suppose performing for the x of 0, y of 0, y of 0 equal to x of 0, y of 0 equal to x of 0, it is also 1. Y of 1, y of 1 equal to x of 2, x of 2 value equal to nothing but a value 2 is nothing but x of y of plus 1 equal to y of x of 2 value equal to 1, so it is a 1 value. Now sir, remaining all sample value become a 0. Because you see the 0 by 2, 0. 1 by 2 is 0.5. What is x of 0.5 value? X of 0.5 value equal to 0. Between the one sample and other sample, the value also 0. This follow. Similarly, you can see that in case of the if time is multiplied by 1 by 2 value, y of n equal to x of n by 2 is a compressed version. The entire value divided by 1 by 2. This is a minus 4. What is x of minus 4 value? You see the x of 0, x of minus 3. X of minus 3 equal to x of minus 3 divided by 2. That means x of minus 1.5. X of minus 1.5 equal to 0. That's why the value will be 0. X of y of minus 2. Y of minus 2 equal to x of minus 2 divided by 2. That means x of minus 1. X of minus 1 value equal to 1. That's why the value equal to x of minus 3, x of minus 2. So y of minus 2. Sorry, y of minus 2 equal to y of minus 2 equal to x of minus 2 divided by 2. X of minus 1. X of minus 1 equal to 1. So 1. Suppose y of minus 1. Nothing but x of minus 1 by 2. It is x of 0.5, minus 0.5. X of minus 0.5 value equal to 0. Y of 0, x of 0. Y of 0 equal to x of 0. Nothing but x of 0 value equal to 1. We put as 1. Suppose x of 1. Sorry, y of 1. Y of 1 equal to x of 1 by 2. X of 1 by 2 value equal to 0. That's why I put a 0 sample. And y of 2. Y of 2 equal to x of 2 by 2. X of 1. X of 1 value equal to 1. We take as 1. Now x of 3. X of 3 equal to x of y of 2 equal to y of 3 equal to x of 1.5. X of 1.5 value equal to 0. Like this. So you observe that in this case, whereas x of n contain five samples are there, whereas y of n, when you can double the scale, time scale, it becomes a y of n contain only 3 samples are there. That means number of samples can be integers. Where in case of the if t can be n can be multiplied by 1 by 2. That means what happens? Number of samples can be increased. That means usually we get 0 samples. 1, 2, 3, 4 0 samples. 3 1 samples are get. Total number of samples equals 7 number of samples. That means more number of samples are occurring when we are doing for the this multiply by 2. The number of samples can increases in the case of the in this case when you do the half of the reduce half of the time. This is about the time scaling operations. Next, you go for time shifting operation. Generally, shifting can be done in time domain by adding or subtracting of the any amount of time to the time variable that gives the shifting operations. That means suppose x of t is a given signal. if our time shifting operation performed on x of t, resulting signal is equal to y of t, that is equal to y of t equal to x of t minus t. That means y of t equal to x of t minus b. This indicating as delay operations. X of t delayed by amount of b seconds. The b is always positive value. Suppose sometime y of t equal to x of t plus b. In this case, b is a negative value. This indicating as advance. Is a x of t plus is an advanced version of the x of t. The x of t minus b is there, nothing but delay version of the x of t. Advance version of the x of t. Okay, this is a time shifting operation. In case of the x of n, discrete time sequence, y of n equal to x of n minus plus or minus b. Let us see. Suppose the x of t is a original signal, it is shifted by amount of 1 towards the right hand side. It is indicating a delay. It is indicating a delay operation. That means each time minus 1 shifted to the 0 and 0 shifted to the 1, 1 shifted to the 2 in this case. But it does not change the shape of the signals. Only shifted operations. Similarly, x of t plus 1 is nothing but advanced. X of t plus is advanced by amount of 1. In this case, they shifted by left hand side direction. That means 0 shifted to minus 1, 0 shifted to minus 1, and 1 shifted to the 0, and minus 1 shifted to the minus 2. Like this, without changing of the shape of the signal. This is advanced version. Advanced. That means x of t1 is advanced by amount of 1, or advanced version of the x of t by amount of 1. X of t is the delayed version of the x of t by amount of 1. This is called the shifting operations. Next, time reversals, folding and reflection operations. In a special case of time scaling operations, in which whereas time scaling operation, a value is always positive values. Okay, and a value lies between the greater than 1 or a value lies between the 0 and 1 values. But in this case, a value is equal to minus 1. That is called special case of scaling operations. Next, the dilation and time reversals are commutative operations. In case of time scaling operation, x of t is nothing but a original signal. X of minus t is a time reversals of the x of t, or folding of the x of t, or mirror image of x of t. That's why when you do the folding operation, left side become right side, right become left side. That's why the x of t signal is like this is red line and yellow line. This is a lies on the right hand side. When you do the time scaling operation, it move to left hand side, like yellow and here move to other left hand side. That it become in this case green and red. It lies in a left hand side. It move to right hand side. So this just it in a changes left become right, right become left. This is called the time folding operations. Example: let us say x of t is any tape recorded audio recorded tape. X of minus t indicating that the recorded tape can be played in backward direction. That is example for the time reversal operations. This I can stop this lecture. We conclude that in this class I can cover the operations on amplitudes and operations on a time. But when you perform operations on amplitude, it does not affect on the time. When operations performed on a time, it doesn't affect it on the amplitude. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.